Okay guys, this is the lesson 7.3 video, and we're going to prove triangles similar in this lesson by shortcuts. Okay, so this sort of follows from what we were doing with congruency a couple chapters ago. Remember that in order to prove triangles congruent, we had to show that the corresponding sides were congruent and the corresponding angles were congruent. Alright, and then once we kind of learned that, then we learned shortcuts in order to make it easier. So the shortcuts we learned were the side, 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 angle, side, angle, and angle, angle, side. Alright, 2 sections ago then we learned how to prove that triangles are similar. We said we have to make sure that the corresponding sides were proportional and the corresponding angles were congruent. In this lesson we're going to learn the shortcuts: angle, angle, similarity postulate, side, angle, side similarity, and side, side, side similarity. So these are going to be our shortcuts to prove triangles similar. We're going to begin with angle, angle, similarity. This postulate says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So angle S is congruent to angle M, angle R is congruent to angle L. So we have 2 pairs of angles congruent, so the 2 triangles are similar to each other. Alright, in problem 1, are the 2 triangles similar? How do you know? Well, let's look at it tells us to look at RSW and triangle VSB first. What I notice is I have a 45-degree angle here and a 45-degree angle here. So I have 1 pair of congruent angles. Now, I need 2 pairs in order to prove similarity. So, do I know another pair? And the answer would be yes. I know that this angle right here is congruent to this angle here because they're both vertical. So triangle RSW is similar to triangle. Make sure you're matching up the corresponding part. So R corresponds with V, S corresponds with S, and W corresponds with B. Alright, so there's my similarity statement. And then how do you know that they are similar? By angle, angle, similarity. Alright, in part B, we look at triangle JKL and triangle PQR. Are these similar? Alright, so what we have to do is find the missing angle. So if this is 30 and this is 70, then we know that this angle right here, K, is 80 degrees. Okay, and then P, if this is 85 and this is 70, this must be 25 degrees. Now, do I have 2 pairs of congruent angles? The answer is no. So these are not similar. Because only 1 pair of congruent angles. Alright. Moving along, now we're going to talk about the side angle side similarity theorem. So it says if an angle of one triangle is congruent to an angle of a second triangle, then the sides that include the 2 angles are proportional. If an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the 2 angles are proportional, then the triangles are similar. Alright, so these sides right here are both proportional. The angle between them are congruent. Alright, remember this is the included angle because it's between the proportional sides. Alright, so if this happens, we can prove the triangle's similar by side angle side similarity. Alright, side similarity. What does that mean? That means that all of the sides are proportional to each other. If that's the case, the triangles are similar. Okay, let's look at problem 2. Are the triangles similar? If so, write a similarity statement for the triangles. Alright, so what I like to do with these problems is when they're not drawn in the same orientation is to redraw them so they match up. So I redrew this triangle. Alright, so I'm going to kind of get rid of this. Don't want to look at it anymore. Alright, and so we got to determine if the triangles are similar. I'm given nothing about the angles. Alright, so because I'm not given anything about any angles, I can rule out side angle side, and I can rule out angle angle, and just check for side side side. Okay, so I'm going to write 10 over 15. Does that equal 8 over 12? And does that equal 6 over 9? So you see how it makes it easy here to match up the corresponding parts. Right, so 10/15, I can reduce that to 2/3. 8/12 reduces to 2/3, and 6/9 reduces to 2/3. Okay, so triangle UST is similar to triangle WXV by side similarity. Okay, for part B now, I want to again see if these triangles are similar. Alright, and if you're confused by this, go ahead and press pause and redraw this. And that's what I'm going to do right now. Okay, so I've just separated the triangles. Again, if it looks confusing, that's always a good thing to kind of do, is just to separate the triangles, redraw, and relabel. Alright, so what I have here now is I notice that I have angle K in both of these. So angle K is congruent to itself by the reflexive property. Now, what I want to do is see if the included sides are proportional. All right, so is this side? Oops. Are these two sides proportional? So what I want to do is say, okay, KL is 8, so I have 8 over, alright, and then the corresponding side is KM, and KM is 10, so I have 8 over 10. Does that equal, alright, I have KP here, so that's 12 over, alright, and then KN, which is 15. Alright, so if I divide by 2, 8/10 by 2, I get 4/5. Alright, and then does this equal 12/15? Or if I divide 12 by 3, that's 4. Divide 15 by 3, that's 5. Alright, so the included sides are proportional. So triangle KLP is similar to triangle KMN by side angle side similarity. We're going to skip problem 3, alright, and go straight to problem 4 here. So it says, we got this picture. It says, before rock climbing, Darius wants to know how high he will climb. He places a mirror on the ground and walks backwards until he can see the top of the cliff in the mirror. What is the height of the cliff? And so we have this picture that we just want to kind of pay attention to. So we're interested in finding the height of the cliff right here. Alright, and notice how I have two triangles. Now, these two triangles are similar to each other because I have two pairs of congruent angles. So since the triangles are similar, it means that the sides are proportional. So this side right here is 5.5. Oops. Alright, and what is the corresponding side with that? So in this triangle, the corresponding side is JS. And what is JS? JS is X. That's what I want to find. Now, this is going to equal 6 over 34. Now, notice how I went from I went from small to big, small to big, and I was consistent. Alright, now all you have to do is cross multiply. Alright, and so I'm going to have 6x equaling 34 times 5.5. And that's going to equal 187 divided by 6, and we get x equaling approximately, so x is going to be approximately 31.16. I'm getting close to that, and that repeats. Alright, so hope this helps and you're ready to answer more questions involving similar triangles.